All right, welcome to video 3. Coincidentally or not, this is also my third shot at this video, which you don't know because I deleted the others, wasn't happy with them after I stumbled through some of the math. So here we go again. Here we go for the first time for you guys. We're going to look at a derivation of the um, derivative of the absolute value of x. Now, we know that the function looks like this. We know it's 1 to the right, negative 1 to the left. But how do we actually come up with a derivation of this? And how do we write that as an equation? So let's start by rewriting absolute value as the square root of x squared. We square a number, it becomes positive. We take the positive's root, it goes back to the original number, but it's now a positive. We've eliminated the negative. And then we can write this as x squared to the 1/2 if we write it as a power. And this becomes a simple derivative. We've got power rule, 1/2 x squared to the negative 1/2 times chain rule. The derivative of x squared is 2x. Rewriting this, we have 2x over 2 times the square root of x squared. The 2's reduce, and we may notice that the square root of x squared is in fact absolute x. So this derivative becomes x over absolute x. And if you think about it, this is always equal to 1, but if x is positive, this will be equal to positive 1, and if x is negative, then this will be equal to negative 1. So in your notes, you can go ahead and write down the derivative of absolute value of x is x divided by the absolute value of x. Cool. Let's look at an example, and we're going to use a little bit of graphical graphing strategy here on this one, and our function is equal to the natural log of absolute value of x over 1 plus x squared. Now, one thing that's going to be important to notice is let's take a look at the graph of this function. I know that natural log looks like this, and it has a domain of x greater than 0. But because of the absolute value, if x is negative, or if the input is negative, I'm just going to turn it into a positive anyway, which means that my domain actually becomes x is not equal to 0 for this function. Okay, derivative. So I am going to tell you the derivative. I'm going to tell you that my outer function is natural log, that my middle function is absolute value, that my inner function is x over 1 plus x squared. I am going to let you, if you are interested, come up with the derivative by working your way through it. And what I am going to tell you is that the derivative of this function is 1 minus x squared over x times 1 plus x squared. At this point, you should be able to find that derivative, and I don't want to subject you to all the algebra involved in finding this. All right, let's take a look at critical points. Critical points. 1, f prime equals 0. Well, clearly, f prime only equals 0 when 1 minus x squared is equal to 0, which means that x equals plus or minus 1. There's 2 critical points. 2, f prime does not exist. Well, x equals 0, then this will not exist. But 1 plus x squared, never 0, so that's the only place that this doesn't exist. Now notice that the domain does not include 0. This is not a critical point because that number is not in the domain of this function. All right, let's talk about endpoints. Endpoints. Well, this function goes on forever. X goes to infinity, x goes to negative infinity. And if we go back and we look at x equals plus or minus 1, what we discover is that f of 1 is equal to the natural log of 1/2, and that f of negative 1 is also equal to the natural log of 1/2. So those are going to be either minima or maxima. So graphically, the question is, well, what does the function do at the endpoints? Is this a maximum, or are these minimum, or is it one of each? So by looking at the endpoints, we can figure that out. So looking at the original function, if x is going to infinity, then x over 1 plus x squared goes to 0. But the natural log of something that goes to 0, theoretically, I would say the limit as x approaches 0 of natural log of x from either side is actually negative infinity. So if I'm looking at a graph of this function, what I discover is that as x goes to infinity, this goes down. In fact, you know what I'm going to do? I'm going to erase this graph because I now know a bit more about what the graph should look like. And I'm just going to start this graph over again because here's what I had. I've got 2 points, 1 and negative 1. I know that the natural log of 1/2 is some negative number. And as x goes to infinity, this function goes down. What happens as x goes to negative infinity? Well, I get the same thing. X over 1 plus x squared goes to 0. And technically, this is 0 from above versus 0 from below, but it doesn't matter because the limit as x goes to 0 when I'm taking an absolute value, still negative infinity. As x goes to negative infinity, this function goes to negative infinity. And I know that the function does not have an endpoint in the middle here as x approaches 0 from either side. But since this is a critical point, this must go down. I don't actually even have to explore what happens as x approaches 0 because my critical point has to be a max or a min. If I started negative and I came up to my critical point, has to go back down again at this. Wow, is that a true statement? Didn't I not earlier say that critical points did not have to be max or min? So no, I just lied to you. Uh, oops. Let's roll past it. What happens as x approaches 0? As x approaches 0, the function approaches natural log of 0, which is negative infinity from both sides. So now I know graphically that it goes down as it approaches 0, which means that these are absolute maxima and that there are no absolute minimum. The function keeps going down forever. All right, good. We recovered from that one little glitch. If you're in my class, why don't you go ahead and do exercise 37 in the book? And if you're not in my class, or if you are in my class, guys, this ends section 5.1 in the book pretty quick. Just some examples of how to use derivatives to find extrema. And I'll be back with a quick recap video to wrap up section 5.1. Hey, thanks for watching. Hope you learned something.